Good day everyone, welcome to this video, and today in this video we'll tackle about hypothesis testing. Hypothesis testing. Hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. So there are two types of statistical hypothesis. First is the null hypothesis, which is symbolized by HO. So when you say HO, it is mu sub 1 is equal to mu sub 2. So from the word equal, it shows that there is no difference between the two population means or parameter. So it is equal, there is no difference. So the second type of statistical hypothesis is the alternative hypothesis. So it is symbolized by H1. So when we say alternative hypothesis, the mu sub 1 and mu sub 2 are not equal, or our mu sub 1 is greater than or equal mu sub 2, or our mu sub 1 is less than or equal mu sub 2. So when we say not equal, greater than, or less than, it shows that there is a difference between the two population means or parameter. So they are not equal, they are greater than or less than, so there is a difference. So in our one tailed test versus two tailed test, when we say two tailed test, it is equal. It means the left and the right are tested. They are just equal numbers. So in our one tailed test, if the result of our problem is less than, we go to left tail. If greater than, we'll go to right tail. So in addition, in our decision rule, when you say two tail tests, they are equal in both sides. When you say these are shaded region, this part here, the shaded region, is the rejection region, and here or here, this is non-rejection. When we say this is positive 1, so this is negative 1. So when we say in our result of our problem, the result of our problem is positive 2. So the positive 2 is here, positive 2. So positive 2 is here in our rejection region, so we will reject. In one tailed test, if the result of our problem is less than, it is in left. The left tail only has shaded region. When we say greater than, so the right tail. So in our example, a researcher reports that the average salary of a college dean is more than 50,000. A sample of 40 college deans has a mean salary of 55,300. At the alpha is equal to 0.01. This is the claim that the college deans earn more than 50,000 a month. The standard deviation of the population is 5,250. So this is our given. The mean or the x bar is equal to 55,300, and our mu is equal to 50,000. Our standard deviation is 5,250, and our n is 40. So in our solution, step 1 is state the hypothesis and identify the claim. So what is our claim? Our claim from the problem is the college deans earn more than 50,000 a month. So from the word more than, it is greater than. So we'll put our claim on alternative hypothesis. Since alternative hypothesis, there is a difference between two populations, so our mu is greater than 50,000. Since our problem has no, and our HO or our null hypothesis is mu less than or equal 50,000. On our step 2, we'll just find the level of significance. So our level of significance is alpha is equal to 0.1. Where did I get the 0.01? Here, from the problem, alpha is equal to 0.01. So step 3. Step 3 is find the critical value. So where did I find this positive 2.329? I find this, I get this in our Z table. 0.01 one-sided. Here 0.01 2.326. So take note, we can use z-test if our n is greater than or equal 30. Since our n is 40, we can use the z-test or the z-test table. So after getting the critical value, we'll find the z value. So the formula of the z value is equal to x bar minus mu over standard deviation over the square root of n. So you will just substitute from the given and we can get 6.395. So in our step 5 is the decision rule. Since our critical value is positive 2.326, so we'll put here 3.326 and shade the right tail since it is more than or greater than from our problem. After that, since our z value is positive 6.395, so here from our 2.326 will the 3.365 is, I think, somewhere here, 6.395. So since our 6.395 are inside in our rejection region, therefore our null hypothesis is rejected. So in our step 6, which is the conclusion, since we reject the null hypothesis, we can conclude that there is enough evidence to support the claim that the monthly salary of college deans is more than 50,000 a month. So that's all for this video. I hope you learned something. Thank you for watching and goodbye.